Hi everyone, in this video I'm going to talk about a package called Ruptures that is for offline change point detection. It means actually the data is not real time, and you can have a look at the documentation of this package, and this package provides methods for the analysis and segmentation of non-stationary signals, and it can be used for outlier detection in a time series data, or you can divide your time series data into segments with this package. First, you need to install the package as always, and you need to import it. And after cleaning the data, I have a data set about the electricity usage for a period of time. And I have two columns, the time column and the usage column. And let's plot it, and we can see some changes on our time series data. And let's detect the changes automatically with the help of this package. And there are two ways to do this. And first you can use the dynamic programming method. And if you know the number of change points, you can give the number of change points and allow the algorithm to detect these changes. And the mean size argument means that the number of samples between two change points, and we need to fit the data, our time series data. And as I said before, if we know the number of change points, it's called dynamic programming method. We could use the dynamic programming method, and we need to give the number of change points. And after running this, we can see the change points. We detected the change points on our time series data, and it seems like that we said that we divided our data into 7 segments. So we said that there were 7 change points. So we can see that 1, 2, 3, 4, 5, 6, and 7 change points are there, and we can display it. And if we want to point out some changes, especially with bold lines, we can implement it. Let's change the number of change points and discover the other numbers. And let's say 5 change points, and if we run it, and the change points start differing, and actually it's not what I want. So let's say 8 change points, and if we run this cell, we can see that there are four events. There are four events in my time series data, and I detected all of them successfully. So maybe in this case, 8 is the correct answer for us, and we can use it for this case. And if we don't know the number of change points, we could use the PALT method, and in this case we don't give the number of change points because we don't know it, and we can give the threshold to penalize the data changes. And for example, if we give 2, we can see it, the result. And if we change the threshold, probably the output will change also. We can play with numbers here, and we can find the correct threshold, or the number of change points for us. And finally, I would like to mention the two options we can apply. One of them is RBF kernel, and actually it can detect changes in the distribution of our time series data, and the other kernel is the linear kernel, and it can detect changes in the mean of a time series data. The difference between between these kernels is that actually one of them can detect changes in the mean of a signal. The other can detect changes in the distribution of a time series data. And thank you for watching, and I hope you enjoyed this lesson.